Good day, we'll discuss apportionment. The mathematics on apportionment involves the problem with dividing up the fixed numbers of groups in different sizes. In the political field, it takes the form of the allocation in the limited number of representatives for voters. So the main objective of this apportionment is to have a fair distribution of things. So the things being divided can exist only in whole numbers. Of course, when we talk about people, we cannot have zero point 0.5 or 3.5 numbers of people. Okay, so it must be a whole number. Number two, we must use all of the things being divided up and we cannot use any more. So if you're asked to divide this specific number of people, all of them must be used up. All of them must be distributed to a specific group or part. Number three, each group must get at least one of the things being divided. Of course, each group must have at least one thing or one representative. And last, the number of things assigned to each group should be at least approximately proportional to the number or to the population of the group. Take note of this, proportional. So it's not about equality. Okay, say for example, if we have uh, 10 people that you need to be divided in, say for example, three sections where okay, we have this. Say for example, we have three sections and we will divide them accordingly. Okay, so it does not mean that if it is three, so we must exactly divide it by three to get all of them a fair equal part. No, it's not that way. In apportionment, we must consider its population. So basically, the group or the section with the highest population should receive more representative from these 10 people. So it must be proportionate to its population. So maybe if number 3 has the largest population, so we can have 3, 3, and the section 3 will have 4 representatives. But of course, we have some techniques or apportionment rules to follow. Okay, so note if group A is larger than group B, then group B shouldn't get more of the things than group A does. Okay, because again, we'll have to do this, the proportional to its population. So if A has a larger group, then most probably he must have a large number or a bigger number of representatives or representative. Okay, so we will only discuss three methods: Hamilton's method, Jefferson's method, and Huntington-Hill's method. So Hamilton's method. So it was proposed by Alexander Hamilton, and his method was approved by Congress in 1791 and voted by President Washington. The method determines how many people in each representative should be represented. So again, it's all about fair distribution. So we must distribute this representative to a fair or to a proportion must be proportional to its population. Okay, so we'll have these four procedure: calculate the standard divisor or divisor, calculate each state's standard quota or quota, initially assign each state in its initial quota, and find the final quota. Okay, so now let's go through each of these procedure. Okay, by having this first example. So the country of Henovia has three regions: Luvania, Andalusia, and Malicuria. Henovia's House of Representatives has 41 members. So take note, we have 41 members. Now let's use Hamilton's method to apportion them, meaning to divide them fairly to Luvania, Andalusia, and Malicuria. So these are the data. So these are the population. So the total is 897,934. Now step 1. Calculate the standard divisor. So let's label it with SD. So this is to determine how many people each representative should represent. So it means about the population. How many people each. So meaning out of the 41. No, for every member of the 41 members, how many people must they handle or must they represent? So this phase is to divide the total population of all the states by the total number of representatives. That is called the standard divisor or the divisor. So meaning the total population is this one divided by the number of representatives or the things that should be divided. So here we have the number of representatives, which is 41. So we must divide these 41 members or representatives. So basically, by just looking at this population, we can infer that Andalusia must receive more number of representatives, because based on this population, it has 538,000 people. So by proportion, so it must have a greater or larger number of representatives. So now let's check. So first, let's solve for the standard divisor. So the total population divided by the total number of people that should be divided. So we have 897,934 divided by 41. So it is 21,900.82927. So as much as possible to minimize error, you may write all the numbers on your calculator. So see to it that your calculator is not on scientific notation. Okay. So for the first part, for the standard divisor, I suggest that you copy all the numbers on your calculator for SD. This is again to minimize the error. So example 1, procedure number 2 or step number 2. We must now calculate each state's standard quota. So divide each state's population or country's population by the standard divisor in order to determine how many representative each should have. So the record of the answer should be rounded off to 4 decimal places. Now this time, for us to be uniform, so let's round our standard quota to 4 decimal places. Okay, to 4 decimal places. Round off. Okay, up to 4 decimal places. So again, we must divide the state's population. So this time, so each specific population. No, in the previous one, in number 1, it must be the total population. Okay, so the total population. Here, for step 2, it must be the specific population or of the country or state. So 162 divided by 162,310 divided by our SD. So this is computed on step 1. So we have 7.4111. Andalusia 538,479 divided by our SD. So we have 24.5872. And Malicuria 197,145 divided by our SD. So we have 9.0017. So that is step number 2. Now step number 3. Step number 3 is initially assign each state its initial quota. It's initial because we cannot say directly that these numbers will be our final answer. Okay, so most of the time it's not our final answer, so we must adjust some things. So that is why we have the initial quota. But in case for step number 3, if the answer is now acceptable, then we will stop at example or at procedure or step number 3. Okay, so in step number 3, we must cut off all the decimal parts. Cut off. So we must not round off, we must not round up. We must just cut off, meaning erase. Okay, then add the initial quotas. The sum is always, take note of this, the sum is always less than or equal to the total number of representatives. So if the sum is equal, then we are done. We will stop at number 3. Our initial quota will be our final quota. But if it's less than, then we'll proceed to step number 4. Now, let's go back to our example. So from our standard quota, we have this, our previous solving, or for this one. So I just deleted this solution. So we have this. Now, cut off. So meaning we'll just erase this. Do not round off, do not round up. So cut off. So meaning we have the initial quota 7, 24, and 9. So it's equal to 40 if we sum this up. 7 plus 24 is 31 plus 9 is 40. Now take note, we need 41. So that is why I just labeled it with initial quota. Now we must have 41. Take note, all of the representatives must be distributed. No one should be left behind. So because of this, we must go to step number 4 to find our final quota. Now take note, if the result in step 3 is equal to the number of representatives, then the initial quotas will be our final quotas or answers. Okay, so we'll just stop here if it's already equal. Now, if the result in step 3 is less than the total number of representatives, then the remaining representative, so which is only one, because we have 40, so we have one representative left to be distributed. So it should be given to the state with the largest decimal value. Take note, largest decimal value. So let's compare. So this is our initial quota. Of course, the total is 40. Now, for step number 4, we will go back to our standard quota, our SQ. And this time, we will just only look at the decimal places. So meaning, let's start with the tenths value. We have 4, 5, and 0. So which of these is the largest? So the largest, of course, is 5. Okay, so the largest is 5. So therefore, the one representative that is missing here, the one representative that is missing must be put in Andalusia, because again, based on this, it has the largest decimal value. Okay, so we have 25. So now we have our representatives. All of them are being distributed. Okay, no one is left behind. Now, if in case we have this, say for example, the first one is 7.5111 and the other one is 24.5872. Of course, both of them have the same tens place, the first decimal place. Okay, now if that is the case, then move to the next decimal place. So we have now 1 and 8. So of course 8 is larger, so we will choose this one. Okay, so again it's still Andalusia. So the point here is we must look to a larger decimal value. So just move. If they are the same, move to the right. If they are the same again, if this is 8, then again move to the third decimal place. Okay, in order for us to find the largest decimal value and for us to distribute the remaining representative. Now let's go to example 2. So if a country had 4 states with the populations given on the table, moreover its government had has a 20-seat House of Representatives. Use Hamiltonian apportionment method in determining the number of representatives from each state. So we have now 4 states, the north, south, east, and west. And we will now use the apportionment. Now, what is step number 1? Step number 1 is to compute for the standard divisor. Okay, and for the standard divisor, it must be The whole population divided by the number of people or representatives or things to be divided. So in this case, we have 20 seats. Okay, so divided by 20. So 11,882 divided by 20 is 594.1. Okay, so in this case, it has only one decimal place. You may check it with your calculator. So this is now our SD. Step number 2 is to calculate each standard quota. So here we will go now to the specific, to each specific population. So 2,560 divided by our SD, which is 594.1. So this is from step number 1. So we have 4.3090. Sa south, we have 3,315 divided by 594.1. So we have 5.5799. Next, we have 995 divided by 594.1. We have 1.6748. And last, we have 5,012 divided by 594.1. We have 8.4363. So these are now our standard quota. Now, what is step number 3? Step number 3 is for the initial quota, wherein we'll just erase this one. Cut off all the decimal places. So, cut off all the decimal places. So, we have this. So, we have 4, 5, 1, and 8. So, our initial quota is 18. And we need 20 representatives. So, we missed 2. So we must put or we must distribute all of these seats. Okay, so we will proceed with step number 4. Step number 4 is we need to compare these decimal places. So one at a time. Now this one at a time. Okay, so we have, so do not mind the 4, 5, and 1. Just mind the decimal place. Okay, so we have 3, 5, 6, and 4. So one at a time. So who is the highest? We have 6. Okay, so the first one out of the two representatives or seats, 2 seats. So we must distribute it to east. So because it has the largest decimal place. So we have 6. So this one. So this is now our 2. One of the 2 remaining seats. So we have this, our initial is 1, so plus 1, we have now 2. This is the first distribution out of the 2, 1. We must not distribute all the remaining 2 to to east alone, okay? So we must distribute them, if it's 3, 4, and 5, one at a time, okay? One at a time. So since there are 2, so the first one is given to the east. The next one is the next higher. So who is the next higher? We have 5, 3, and 4. So the next higher is 5, higher decimal place. So 5. So meaning the last one, the last remaining seat should be given to the east. South. Sorry, to the south. So we have 5 plus 1 equals 6. So now we add 4 plus 6 is 10, plus 2 is 12, plus 8 is 20. So meaning this should be the final quota or the final distribution of the 20 seats. So meaning north must have 4 seats, south must have 6 seats, east must have 2 seats, and west must have 8 seats. Okay, so you may practice this one. So Jefferson's method, this will be our second method. Thomas Jefferson proposed a new method called Jefferson's method. This differs from Hamilton's method on how to resolve situation when the initial quota or the lower quota is less than the actual seats available. So recall that in Hamilton's method, we only look at the largest decimal number. Okay, this is how we solve or we distribute the remaining things that should be distributed. Okay, now how about in Jefferson's method? How do we deal with the remaining things? Okay, so we have this. So the process is still the same with the Hamilton's method. They have the same first three steps. 1, 2, and 3, they're the same. But for the last one, for step number 4, it is not, or they differ. So again, we'll have this example. So from our previous example or previous videos, we have this example. So we have 41 representatives for the house for Henovia. And then we have 3 regions. So we have this table for the population. So as a review, the first step is to find the standard divisor. So for the standard divisor, it involves the total population divided by the number of things to be divided, which is 41. So again, we have 21,900.82927. Step 2, the same with the previous video sa Hamiltonian. So divide each population by the standard divisor. So we have this standard quota. And step 3 is we need to cut off all the decimal parts. Okay, so we have 7, 24, 9, and 40. Now, in the Hamilton's method, we only look at the decimal place. The one with the largest decimal place will have the remaining one seat. Okay, take note here we only have 40, but we must distribute the 41, so we're left with 1. Again, in Hamiltonian, we only look at the decimal places. The one with the largest decimal place will get this remaining seat. So we have plus 1 here if we use the Hamilton's method. But in Jefferson's method, it's not the same. Okay? So if the result in step 3 is equal to the number of representatives, then the initial quotas will be our final quotas or answers. So again, if it's equal to 41, then we're done. But if it is less than, if the result in step 3 is less than the total number of representatives, then we will or you will adjust the divisors and then do steps 1, 2, 3. Okay, you adjust the divisor. So it means you will do trial and error. Now, take note our SD is 21,900.82927. So we can adjust this one. Say, for example, I will adjust this to 21,500. So our SD now is 21,500, the adjusted SD. So I will go back to my step 2. So since this is our step 1 already, this is the adjusted one. So let's now go to step number 2. This is our SD. So step number 2 is for the standard quota. So the population 162,310 divided by our new SD or divisor 21,500. So we have this value. Again, for Andalusia, do the same thing. And for Malicuria, do the same thing. Okay? And then step number 3 is we just need to cut off the decimal places. So in this case, we have 7, 25, and 9. So 7 plus 25 is 32 plus 9 is 41. Okay, now if it's, say for example, you just got again, it's again 40, then you just need to adjust again your divisor. Okay, you adjust your divisor. Okay, until you get the exact value, 41. Okay, now in this case, since we already got 41, So these are now our final distribution of the 41 representatives. So 7 for Lovania, 25 for Andalusia, and 9 for Mali Kuria. Okay, let's have another example. So the same thing with the previous one. If a country had 4 states, meaning north, south, and east and west, and they have the government have 20 seat House of Representatives. So in this case, we will distribute this 20 seat to these 4 states. So again, the first 3 steps will be the same or are the same with Hamiltonian's method or Hamilton's method. So the first step is to compute for the SD. So total divided by 20 because there are 20 seats. Okay, so we have 594.1. Step 2, again, the same with the Hamilton's method. Each population should be divided by the standard divisor, which is 594.1. So you may check with your calculator. So these are the values. Okay, and step 3 is just to cut off the decimal places. So this one. So we have 4, 5, 1, and 8. And again, 18. So we are left with 2. No, because we need to distribute the 20 seats. Now, if we use the Hamilton's method, again, we will use we will compare the decimals. Okay, so first we have 6. 6 is the largest, so the first one should be placed here or put here, and then the next one is 5, so the next one should be placed here. So if it's Hamilton, no, if it's Hamilton's method. Now, since this is on Jefferson's method, our step 4 is to adjust our SD. So take note, this is our SD. So we need to adjust this one. So I'll just adjust this to 520. Okay, so 520. So let's go back to step number 2 because this is now step number 1, our SD. Step number 2 is to divide each population by our new standard divisor, which is 520. So we have 2560 divided by 520. We have this 3315 divided by 520, 995 divided by 520, and 5012 divided by 520. Okay, and we will cut off the decimal places. So we have 4, we have now 6, we have now 1, and we have now 9. Okay, because we just cut this. And add 4, 6, 1. That's 11 plus 9. We have now 20. So again, say for example, you got 19. Then again, you adjust your standard divisor. After adjusting, you do again this computation for standard quota, and then delete the decimal places for the final quota, and then add. You must reach 20. Okay. And for the example, so the same example with Hamilton's method, but now you will use the Jefferson's method. So now let's have the last method, Huntington-Hill's method of apportionment. Edward Huntington formulated this approach, building on the earlier work of Joseph Adna Hill, and called it the method of equal proportions. So this is a method of proportional allocation of seats in a representative assembly by minimizing the percentage differences in the number of constituents represented by each seat. Now recall that in Hamilton's method, we only look at the largest decimal number in distributing the remaining other things to be distributed. Now in Huntington's Hill's method, or in This is again not Huntington's method. In the second method, which is Jefferson's method, we modify the standard divisor and repeat the process. Okay, so in Jefferson's method. Now, how about in Huntington-Hill's method? So let's see. So we have this procedure for Huntington-Hill's method. Number one is the same with actually the first three steps is this similar with the Hamilton and Jefferson's method. So we must still calculate the standard divisor and then calculate the state standard quota and assign each initial quota. Okay, and we will label it as n. But in 3 also, we must compute now the geometric mean, which is computed with this formula. Okay, after which we will compare the standard quota. So the standard quota and the geometric mean. Okay, now in comparison, we must compare their answers. So usually we only compare the decimal places. Okay, so we will see it in our examples. Now, if the standard quota is greater than the geometric mean, then we round up the standard quota. If the standard quota is less than the geometric mean, then round down the standard quota. And then we add the numbers, and this is the initial allocation, of course, if the sum is not equal to the number of things to be distributed. Now, number 5, if the total from the previous step is less than, then we adjust the divisor. So reduce the divisor and start over with the computation if the total is less than. But if it's greater than, then we must increase the divisor. So now let's go to example to understand this further. So again, we'll have the same example with Hamilton and Jefferson's method so that we can understand the differences between the three. So again, so this is example number 1. The first step is to again calculate the SD. So we already calculated this one since the Hamilton's topic. So we have this, the total population divided by the number of representatives, or the total of things, number of things to be divided. So that this is our SD. Standard quota is we need to divide each population by its SD. So again, we have this values. And now let's go to number 3. So the same with the Jefferson and Hamilton's method, we can just cut off the decimal places. Okay, decimal places. So the initial quota or the lower quota is now 7, 24, and 9. Take note the total of this 7 plus 24 is 31 plus 9 is 40. Okay, the total is 40. So because of this, we must proceed by computing the geometric mean. Okay, how do we compute the geometric mean? We will use this one. Now, our standard quota now will be our n. So we have n equals to 7, n is equal to 24, and n is equal to 9. So we have now n for the first row. For Luvania, we have n, so 7. 7 plus 1 is 8. So 7 times 8, we have 56. Square root of 56 is equal to this. Next, for the second row, for Andalusia, our n is 24. 24 plus 1 is 25. So the square root of 24 times 25 is this one. And last, for Malicuria, we have n is 9. 9 plus 1 is 10. So the square root of 9 times 10 is equal to this. Okay, now this time, do not cut off the decimal places. Instead, we will compare these two, SQ and GM. So this is number 4. If the standard quota is greater than GM, or the geometric mean, we will round up the SQ or the standard quota. Otherwise, we will run down the standard quota and then we will add the allocation. Now, look at these two numbers, SQ and GM. Now, for SQ, for Luvania, we have 7.4111. For geometric mean, we have 7.4833. So which is larger or bigger? Obviously, this is larger, the 7.4833. Now, according to this, it means that SQ is less than, right? Because GM, the geometric mean is larger, so the relationship of the two is less than. So we follow the second statement. So we will round down the SQ, round down. So since this is 7.4, if we round this down, so we'll just have 7. Okay, round down. So meaning it's an integer, round to the previous integer. So when we say round down, you can just delete the decimal places. Now let's go to the next one. For Andalusia, 24.5872. The other one is 24.4949. So obviously, the SQ is greater than the geometric mean. Okay, so SQ, so meaning we will follow the first statement. So round up the SQ. So meaning we must round up. So 24 will become 25. Okay, round up. And last, for Malicuria, we have 9.0017. The other one is 9.4868. Obviously, the relationship is less than because SQ is really less than GM. So we will follow the second statement. So we will round down our standard quota. So round down. So this will become 9. Okay, and then we add. We have 7, 25, 9, and 41. So this is now equal to 41, which is the required number of representatives. So we stop here. Okay, now let's go to example 2. Again, the same with the Hamilton's and Jefferson's example. So we have 20 seats to be distributed to these 4 states. So SD or standard divisor, the total number of population divided by the 20 seats. So we have 594.1. Step 2 is to calculate the standard quota. So we have each population should be divided to the standard divisor. So we have these values. And then for step number 3 is to find the initial quota. So delete, no, cut off the decimal places. So we have 4, 5, 1, and 8. And the total is 18. But we need 20, right? Because there are 20 seats. Because of that, we proceed by computing the geometric mean. So our n, we have 4. So 4 plus 1 is 5. So we have the square root of 4 times 5. We have this. Next, for the second row for south, we have n is 5. So 5 plus 1 is 6. So it's the square root of 5 times 6. So we have this value. For east, we have 1. So 1 plus 1 is 2. So we have square root of 1 times 2. And last, we have 8. So 8 plus 1 is 9. So we have the square root of 8 times 9. And the next step is to compare our standard quota and the geometric mean. So we have for the north, we have 4.3. The other one is 4.4. So obviously this is less than. 4.3 is less than 4.4. So since it's less than, so we will follow the second statement. So we will round down the SQ. So round down, we'll just delete this. So we have 4. So for the south, we have 5.5, we have 5.4, so the relationship is greater. So we will follow Number one, round up our SQ. So meaning 5 will become 6. Now for the east, we have 1.6, we have 1.4. So obviously again, it's greater than. So we'll follow the first statement. So 1 will become 2. Okay, 1 will become 2. And last, for the west, we have 8.43. The other one is 8.48. So this is bigger. So we must have this relationship, less than. So we will follow the second statement. So round down the SQ. So when we say round down, delete that one. So we have 8. And then we add. So we have 20. So the 20 seats are now being distributed fairly to each state. Again, you may use this problem as your example and use Huntington-Hill's method. So thank you for listening.